To help us understand a little bit of the next few topics on complex numbers pertaining on powers, roots, and etc., let's talk about the Moivre theorem. You'll have a lot of ways to read this one, but the very common is the Moivre theorem. This is actually an identity, or the theorem tells us a certain identity that will help us actually talk about the roots and powers of complex numbers. In this video, we are going to present the item indicated for the theorem, and we'll have three different videos for the proof of some of its connections and implications. Let's actually discuss it this manner. If you have here a complex number and the complex number has any n root, okay, this is actually equivalent to the notation r to the power of n. Okay, we know that it could be expressed in this manner: x plus iy to the power of n. The Moivre theorem tells us this would be equivalent to r to the power of n times cosine n theta plus I sine n theta. This is the Moivre theorem, which is actually a result for a little bit of the series of additions. We will have one video for that. But this purposely tells us that if we have here a certain complex number raised to the power of n, it's actually equivalent to this form, and that would mean it also has an implication if we're talking about the root. Okay, let's say the root of a certain complex number. I'm not going to give you here the equivalent, because we also have other video for that explanation for what would be its form when we talk about the root. Instead of n, the exponent is 1 over n. We know that that's square root or nth root. Okay, we know that to be the nth root of our complex number. Okay, so we have an equivalent as well for that. But this is the Moivre theorem, tells us that if we're going to take the nth power of n of a certain complex number, it's equivalent to the n of your r, or your modulo, and then we have this form here, but your theta would be n times any given theta. Again, as mentioned, we'll have the next three videos pertaining on the proof of some of its implications, and the third one will focus on the proof of this. We also have another video for the proof of the identity equivalent to the z to the power of 1 over n. Thank you very much for watching.